It's my pleasure to introduce Evan. Evan is a software engineer whose passions lie in improving the developer experience by reducing human error, enhancing code health, and optimizing workflows. When he's not thinking about security, informatics, or giving talks about his many projects, you'll find him nomming on Subway cookies or chasing bunny rabbits. Please put an applause for Evan.
Thank you. Cool. Hello, everyone, and welcome to my story about refactoring. But what is refactoring? Well, it's the process of improving horrendous code like this to beautiful code like this, all while ensuring that code still runs, tests still pass, functionality is kept the same, and the user doesn't suspect a thing. This could be done by doing things like changing formatting, renaming variables, updating the structure, or using different algorithms and syntactic sugar. And today, I'll be talking about the story of refactoring a side project of mine that solves, annotates, and validates the minimum paths of this train game. Wow, I'm such a nerd. Anyways, why am I refactoring it? Well, I was a bit stuck, and I wanted some help from others. Not only that, but it was hard for me to easily make changes. And if it was hard for me to understand, well, it would have been even harder for someone else. OK, so how did I get here? Well, often I'll have an idea that I want to implement. And Python is a great choice for doing so quickly. But as I added code, and more code, and more code, it quickly turned from a small script to an unmaintainable project. Do you want to see? No, I won't get you to read the entire code because you don't have to. In the same way that you can often just skim an entire article to get an idea of what it's about, like if we skim through this code, you'll see that, could you say that you have a reasonable idea of what it does, where to start, what it's made of, what's important, how it works? It's quite long. Yeah, my answer to that is no. But when I look at where I'm at now, I can easily hazard that the project has something to do with graphs and annotations and mapping and stats and so on. But why was it so messy? How did it become like this? Well, because no one is perfect and can know what all the future requirements will be, or know all the syntactic sugar of a language, or know or identify when to use design principles and patterns, or have the time to make all these changes up front, since with any piece of code, you can try your best to avoid these problems by having an idea for what to look out for, but you need to stop, step back, and take a look at what you're doing. OK, so if we do that, what can we do? Well, the first and easiest step is to use a formatter. It lets us take messy, long, condensed, and inconsistently written blocks like this, which you can see gone off the screen, and automatically turn them into this, which is much more human readable. And even if I blur the example to simulate skimming it, it's probably a lot easier to tell that the formatted case, we're actually filtering a list. Now, in terms of formatters, there's a couple you can choose from. So you can spend a couple of hours researching each one, taking a look at what they do. No, wait, why do you really want to do that? I mean, if your goal is to learn, sure. But a good methodology to take away here, right from the beginning, is one about pragmatism. Because one of the biggest qualms of refactoring is the amount of time it can take. It's important to realize when something is good enough. So if you're trying to be pragmatic, just pick the first thing you find. I chose to use black. It's opinionated, but that doesn't matter to me. All that matters is that my code is always formatted to be readable and consistent. Because in future, trusting the formatter to automatically fix things and not having to debate with myself or others is what will save time. And if I do find issues, then it's very easy to swap out later because you can just reformat all my code at once again. But even formatted code can still have issues. Formatters won't tell you about code smells like problematic naming, and like single characters, spelling mistakes like Celsius and Fahrenheit, unused code like this last line, or duplicated code. But a linter like Rough will. Linters are great because they can look at all your code as you write it and raise issues for fixing that you might not be aware of. There's a whole list of them, and you don't even have to follow all of them. You can silence the ones you don't like or make your own. But they'll often guide you into good patterns that you might otherwise have not considered. Like this warning I got about my function have too many arguments. At first it made me think, that's silly, what's wrong with that? But when I took a step back and thought about how to address it, it made me realize there was a better way. If we took a look at the beginning, we'll see that there's a bunch of code, and some of that code loads some state into multiple variables, and then we take those variables and we pass them into our function with many, many arguments, and then we pass those variables again individually into other functions. And while this was better than just having everything as global variables, it was so messy. Instead, a better idea was to compartmentalize everything by putting these functions as part of a class. For example, by introducing a data holding class that lets me section off creating, storing, and loading the data elsewhere. So where I was previously passing around all of these arguments, now when I call my function, I only need to pass around this data object, making my code much simpler. What do you think? Is this better? Yeah. Is it the best? No. Why? Well, let's take a look at this distance checking function. You'll see that we iterate over the distance list and get the port name and some distances, and then we iterate over those distances to get the cine name and the expected distance, and then we calculate the actual distance, and then we do the check to see if they're the expected value. But this isn't very intuitive. What might make more intuitive sense is to go through every pair of nodes that we want to check the distance of, and then have a method from an object that calculates the actual distance, and another that retrieves the expected distance. And this isn't only great for readability, but it's also great for abstraction, because now all these functions make it very easy to change the underlying functionality. For example, if we wanted to change and make optimizations to the distance calculation to use a faster algorithm, we can just change that within the function. But instead of passing around an object with data, what we really want is an interface to access particular kinds of data, showing the usefulness of designing around requirements. But what I had really done was apply programming principles, known as interface segregation and dependency inversion, which together both dictate that functionality should depend on abstractions, not the data generated by some unknown entity. And if you're curious for more, these both come from a set of 5 called solid. But if you're not aware of these principles, or you find them easy to forget, then I think a better methodology that I found useful is always telling myself, there's got to be a better way. It might take some thinking, research, or time to find what's available to make code simpler, better, and shorter. But I would have never gotten there if I wasn't always thinking about how to do better. And now that we've got a way to find issues in our code, we need a way to easily address them. And I found the easiest way to do that is to use an integrated development environment like PyCharm. IDEs like PyCharm are quite powerful, letting you out of the box easily do refactoring without any setup. I mean, look, it has a refactoring menu. Isn't that great? And some of the things that I found quite helpful were the ability to rename variables everywhere within my project, or fields and method throughout the entire project. It can also extract repeated blocks of code into a function, or change the signature of a function's definition and updating for everywhere that it gets called. It can also list usages and letting you quickly navigate between them. Or it also lets you move files between folders and updates their usages accordingly. So now you don't have to change all your imports. And it also shows you documentation on hovering, or can even give you more extensive things. And look, I know what you might be thinking. Can't amazing lightweight editors like Vim and VS Code do that too? And yes, as someone who's used both, I'm sure it could. But after I had put on my pragmatic hat on, I thought to myself, is it really worth all the effort it would take to set up when all of this comes out of the box for free? Now, something I forgot to mention that an IDE can also do is help you with types. Unlike other languages, when we're writing small Python scripts, it might not be worthwhile to have types. But as our project grows, type hinting can become super helpful for quite a few reasons. One of these is spotting inevitable human errors. Like here, we write our code to explicitly output a list, but networkx.paths returns a generator. So for example, if we save it as a variable here, and then iterate over it once, we'll get the expected output. But because it's a generator, when we iterate over it again, our output will still be the same, even though we might expect something different from a list. But with the right tools, errors like this can be highlighted for us. Another case is when we're unpacking a nested data type. Here, there's nothing, but if we use some type annotations, now we can auto-complete with strings. Okay, so now that we know what types are important, let's go use them. But Evan, you might say, you have so many functions. That's going to be so much work for your large project. And you're right. But we have technology, and we can automate finding and adding in types for us with a tool called MonkeyType, where for the following function, you can produce stubs like this, and even update your existing code so you don't have to edit it yourself. Of course, we don't need an IDE to benefit from type hinting, but once type hinting is all set up, it lets us run type checking tools like MyPy to ensure the continuous checking for errors and types. Now, I forgot to mention again, type hinting is also really helpful for documentation. Take this function with no typing, for example. We can make some guesses at what most of these should be. For example, we could guess that names are probably strings, and since we're using them to index this paths argument, paths is probably a dictionary that stores a list since we're iterating over the output. And the function says it's returning a set, and we have this dictionary comprehension, so we can make a guess at that as well. But without context, we're still missing a lot of things. We have no clue what positions from edge returns or what direction set from edge returns. And therefore, we have to make guesses at why a connection path is a dictionary. In fact, there's no reason why paths couldn't be a list if, for example, the cities and ports were ints. But if I properly fill in these types, then there's a much better idea that connection path is actually a dictionary mapping between positions and directions. And paths, wait, let me format that. Cool. Is actually a 2D map of names to positions. And if I do some formatting to alias the types, then now it's a lot more clearer that this tuple int is a position. And if I become a bit excessive, I could set aliases for strings as well. Make it much more clear that we're returning a set of directions or we're taking in locations. But what it does mean is that if they need to become classes, then we can easily support that. For example, if we change position to be a class. And with that, maybe it's worth asking, how documented is your code? I don't just mean the number of comments and docstrings you've written, or self-documenting type hints. What I mean is, does it speak for itself through its naming and structure? Like, how easy is it for someone other than you to pick up and understand your code with no context? If we take a look at what my repo would have looked like at the beginning, here's the GitHub page with no description and nothing at the bottom, no documentation, or a README for where to start. So we probably have to read some code, but it's not clear which of all of these files are that code. And even once we do find the file, it's thousands of lines long. And there is no main function to signify where to start. If this was an actual repo, I probably would have given up my hopes of using it or contributing to it by now, which goes to show the easier your code is to pick up and understand with no context, the easier it will be for others to answer their questions or contribute. Now, in comparison, we could look at what we ended up with. Here's the main repo with only a few files. And if we scroll down, we'll find the README, which says that the entry point is the main file in the directory. So if we go to that directory, we can easily find the main file. And then if we go to the bottom of that file, we'll find the main method. And then we'll see that the function being run comes from this helper. So then, if we go to the helper that we easily found in a different file, we can easily follow what comes next after update map and then continue throughout the whole code. In fact, if we look at the entire structure as a whole, you can see how these classes and packages make it much easier to reason about the different components of the project. Not only that, but it embraces another important programming principle. This time, the single responsibility principle, which says that everything should only have one responsibility. You can see the impact if we compare the main function from when I first started. You can't see it, but it's actually quite long. Actually, let's go on a tangent while I'm here. You might have seen the extensive use of named arguments. For example, in world map, which might seem a bit redundant, but that's because I have an utmost adoration for Python's beautiful function argument system. Let me explain why. If we're using another language and we want to set up rotation to default to 0, then we often need a function override. But since Python has default arguments, there's no need for these chained overrides. And often, though, they'll use builders to resolve this issue that let us optionally add this data. But yet another issue lies due to the nature of the required ordered arguments. And that is that there's no knowing whether arguments are set up correctly. In this case, you might have not noticed, but it should actually be width and height, not height and width. Python resolves this with named arguments, and thus also does away with builders, meaning that not only are your functions self-documenting by having constant arguments labeled for you, but now your ordering is redundant. You can set it up however you like. Or more importantly, your code is now always future-proofed against errors under cases where arguments are inserted or ordering is changed. And if this opened your eyes, I'll be at the sprints if you want to contribute to automatically finding and applying these guardrails and enhancements. Anyways, where were we? Yeah, this main function was just too long. And if we looked at the files, you can see how, what are these? What is graphing and graph? What is the difference? If we take a look, graph is actually storing two data classes, one being quite long. Again, you can't see it here, but it has quite a bit of logic. When instead, we could split out them to be their own single files. This might be of concern given the extra imports and files to jump around, but that's a trade-off to consider depending on how long is your class. Okay, now that we've started to update our code, what else can we do? Another good principle we can follow is dry, or don't repeat yourself. It's important for so many reasons. Here, we have some code that repeatedly calculates distances. We could refactor it by first introducing a function for abstraction. and then using that function to provide consistency. And then before finally introducing a loop. Now our code is cleaner and safer by providing safety through reassurance that everything is running in the same way. For example, did you notice that there was a bug in the first example? At the end, it should actually be p3.y minus p2.y. So dry allows us to be more efficient because now we don't need to copy or rewrite code to calculate distance. Or when we want to make changes, like fixing that bug, or in this case, changing the method of square root, we only need to do it in one place and can ensure that a bug fix or functionality is used everywhere very quickly. But where did I apply it in my code? One example is this validation code here that was being used in 2 places. Our first thought might be to create a Utils class. But this is often not a good idea, as it creates a new dependency that incentivizes us to add more small functionality that there isn't a good context for. Instead, this could be moved to be inside validations and renamed to validate with. Or maybe what we should really do is ask ourselves, do we really need this? Maybe it would be better to instead create a grid class that ensures all rows are of the same width. Or maybe we should ask ourselves, if there's a better way, and remove the need for this entirely to instead deal with the issue when it appears. Another place we could remove repeated code is during the annotations. In my map, annotations are what colors the path between a port and a city. And there are grouped annotations for both ports and cities. However, even though these are very similar and are done by the same mechanism, we need to implement this slight difference since ports are annotated through nesting. But conceptually, this is just like recursion with a base case, and it made me think, there must be a better way. And so I ingeniously thought of this, which creates a nested list of specialized functions to be called with another generic function that could be used for both cities and ports and thus deduplicate our code. Did you get that? No. Great, because I quickly realized that I didn't either. And even though I learned that while I could give myself a pat on the back for this brilliant ingenuity, what I really learned is that I should give myself a kick in the bum for this added complexity. Because sometimes using neat coding tricks to simplify code is not the best idea. If it was, all our code would be golfed to be as short as possible, and that's just not readable. So it's often worth considering, will the method of our refactoring really help? Or more importantly, and bringing up another principle, are we keeping it simple stupid? Our aim should always be to simplify a code and remove what might not be needed, not introduce added complexity. Eventually, I settled on a class like this that could be inherited and override to provide the extensibility that I was looking for. But was that extensibility that I needed? Maybe it's worth consulting another principle, YAGNI, or you ain't gonna need it. Because should we really be refactoring for things that don't exist? Thus, I'll still always have the feeling that there's got to be a better way. Okay, but how can we be confident that we can make all these changes while keeping functionality the same? Well, isn't that what tests are for? In fact, having good tests is likely one of the most important things to have while refactoring. Because if we have tests to lean on, then we can make all the changes that we want, run our tests, and if they pass, then we're good to go. Tests aren't always the easiest thing to set up though, especially under complexity. But even having very basic tests where a program's correctness might even be manually verified is better than nothing. Since once that's done, it can be a starting point into automating it using integration tests, since with lots of refactoring, unit tests may require too many changes. For example, this data class takes in some file names and creates some state, which can be easily tested via an integration test. As in our test, we can just create the file to test against. But it may become really hard to test the functions of a class like this, as different files will be needed to be created for every test. Not only that, but it's not clear what's inside these files. If you haven't noticed, this is because it violates the Dependency Inversion principle. And a way we can fix that is to instead change our class to be composed of this data. and then use a class method that would take in these file names and create the data needed to pass into the class. Now, in our code, we can continue to create data using the file names, but in our tests, we can specify the data that we want to be used, which makes things much clearer. And now, while tests might ensure that your program stays the same, they don't really ensure that your program doesn't slow down. It's often not obvious when code can be slow, especially with Python, and more so when we're trying to ensure that we're not spending time in premature optimization. This is where a profiler like Scalene can be helpful in analyzing the runtime of our code to determine where there's inefficiencies in computing or memory. For example, this was the output I got when I started to notice my code started to be slow, and I couldn't really figure out what change I did to cause it. And here we can see that this is actually caused by the creation of coordinates. Because what I had done was set up my code in such a way to compute the values of a field on the class's creation, but the edge nodes aren't always needed. Instead, I could move this field to a function instead, only being run when needed. But maybe I wanted this as a property, since it's easier to read and implies it's a value that shouldn't change. Well, we can do that with a property built-in decorator, which lets us return a function's output as a field. But a value shouldn't always be recomputed if it's not going to return the same thing. This is where the functools.cache decorator comes in, which saves the output of a function so that we don't have to recompute it. This is great for values that we access many times, but only want to compute once. We could use both to solve this issue. However, it's worth noting that it can lead to memory leaks, as the cache may retain instance references, preventing garbage collection. The solution is to use the cached property decorator, which does both in one go. And easily one of my favorite Python built-ins, and one that resolves so many linter warnings too. All right, that's our profiling and optimization done. But I wonder whether my refactoring story would be fast or slow if I profiled it. How much time do I have left? OK, well, that was quite a fun story. You might be wondering, though, what about the profit? Did I get the help that I needed? Yes, I did. But there's still plenty more to figure out. And while you could say that there is profit in saving time in the future, I think the real profit, though, was everything that I learned along the way. If you wanted to profit yourself, I've put up some resources here that you can reference later. I'll leave this on for a couple seconds. Cool. You can also talk to me later. But yes, I want to say thanks to my partner and all my friends for supporting me, and thanks to all of you for listening. I would love to hear any feedback that you have. I'm always trying to improve. And you can find me online at ecohilas or GitHub if you wanted to take a look at my code. However, I won't claim that my code is perfect because I think there's always a better way. You can also find me in person right here, as I think we still have some time for questions. Thank you.
Yep, I think we've got time for questions.
Yes. I'll put the QR code up as well.
Hi. I think that was a great talk.
Thank you.
But I do have a questions. In an ideal world where you go into a project, there's a whole bunch of tests, 100% coverage, for example, then you can ensure that your changes or your refactoring doesn't accidentally change any functionality. But there are cases where you go in and there's no test. What would you do in that case to ensure that you don't accidentally change things?
Yeah, that's really hard. So when I started, I basically had this tool that I would run, and I didn't have any tests because I just wanted things to work. And what I did was I just would run it and then visually check it. Would run it and really visually check it. And I would do that over and over. And I think you need to have some kind of test. You need to have some kind of method, even if it's just like create an instance of what the output should be and then check that it's the same. And then at some point, once you've started refactoring and changing all that, you can then start to introduce better tests that you can make sure that all this is the same. In terms of existing code bases, I'm not 100% sure. I guess look at the entry point and the exit point and see what you're trying to compare. It's probably a topic for another talk on testing. Yeah, does that answer your question?
Yeah, thank you.
Awesome, thank you.
Hi, this is a question about typing and documentation. So when using, say, Django, it's hard to use MyPy because, for MyPy to work, it has to run all the code, and that's really hard with Django. So typing is not that useful because there's all these libraries that enable using MyPy, but they're a pain. So typing isn't that useful in Django. Is there a format of sort of docstrings that you're aware of that are a good replacement for typing? Yes. So you don't actually need to use MyPy to tell you whether things are correct or not, and you don't actually need to put in the typing. You can also just put comments. That's originally how typing was done. There's a certain syntax, I don't remember. You can also just use docstrings, as you mentioned, to you can use docstrings to just make your own system or use an existing system. Because really, like, the point, if you have typing, it's nice because then you can validate against everything. But you don't really need that validation. What you really need is some way to, you might be working at something and then you want to check, okay, what is this function outputting? If you just go to that function's definition and then look at the docstring, provided this developer has put something there for you, even that's a really good start. And then over time, when things get better, you can start adding more typing, etc. Does that help? Yeah. So my problem is there's no PEP for docstrings where it says how to define arguments.
Right. Okay. I have a feeling that there should be. I'm not sure. I think I've seen a linter warning where it's something like ensure that it tells you what it returns. I think I have seen functions that tell you takes in these arguments, returns this. It might not be a type definition, but it might just be like a wordy definition at the least. It's a hard question. Yeah, it's a hard problem.
And would you ever prefer, so sometimes when the typing is a complex thing, it's a dictionary of lists of sets of whatever, do you sometimes prefer to just omit that and just write a docstring describing what it is and adding context to why this is what you want in this function?
Yeah, I had that case pop up when I was importing JSON, and the JSON would be converted to dictionary, and it was this massive, really long dictionary with could be a string or it could be it could be a string or it could be an int or etc. etc. I think in that case I just opted to remove it. But another thing you could do is to just save that as an alias somewhere. And just say, okay, this returns a JSON, and the JSON is formatted like this, and then call it a day. Yeah.
Yeah. Thanks.
Thank you.
Thanks, Evan, for a great talk. Here's a token of our appreciation.
Thank you very much.